This is section 9.3, matrix operations and their applications. We'll begin by just talking about what is a matrix. So a matrix is simply a table of numbers. When we were doing ordered pairs previously, that could have been organized as a matrix. And so it definitely connects back to what we've covered in this course. When we talk about the order of the given matrix, we're talking about the dimension or like the size of the matrix. So here we'll always organize this rows by columns. So we have rows, row 1, row 2, row 3. And then for columns, we have column 1, column 2, column 3, and column 4. So this matrix would be a 3 by 4 matrix. And then many times when we refer to a matrix, it'll be titled with a capital variable letter. So in this case, this one is capital A. And when we talk about the elements of the matrix, we're just referencing the different terms of the matrix. So each of these are terms of the matrix. And we locate those by this notation right here. So element, you see it's a lowercase a, element A, and then the subscript ij will represent the row by the column. So on this first one, let me erase what I wrote in there. This first one, element A32, it's telling me rows. So third row, 1, 2, 3, and then second column, 1, 2. So I'm referring to 1/2. And that sort of tells us where to go in the matrix, or it's how we can communicate what element of the matrix we're talking about. Okay, the second one is element A23. So this one will be, let me erase what was there. Row 2, so row 2, column 3. So -9. And that's all you'll do when they refer to an element in the matrix. Here they show us two matrices that are set equal to each other. So that means that every single element in a given spot will be the same as the corresponding element, right? So in the top left corner, I have X on the first matrix, but then in the one that it's set equal to in the top left corner, I have 17. So because these matrices are set equal to each other, I know that those specific elements have to be equal to each other as well, right? So they want us to find the values for the variables. So X is 17, and I just did that by looking here. Y, the only place I have a Y is here in the top right corner, right? And then I have a Y over here. But notice that it's not just a Y, it's 6Y. So 6Y equals 6. If I isolate that Y, so I just have Y, I'll have Y equals 1. So notice I didn't have to do that with X, right? And then for Z, I just have a 1Z. And it's equivalent to 7. So don't overthink that one. That one is just whatever you see in that left matrix. If it's set equal to the right matrix, then it has to be equivalent to that. In regards to X and Z, it gives you a straight integer that you could set it equal to. In regards to Y, we had to do a little bit of solving equations there, right? Okay, addition and subtraction through matrices. So anytime we add or subtract matrices, they have to have the same dimensions. So we talked about the order of a matrix, right? And that was just the dimensions, rows by column. So it has to be the same here in order to add or subtract. Otherwise, we can't add or subtract, because then I'll have a row or a column that has values in one of the matrices that I don't have anything to add it to in the other one. So anytime we're adding matrices, notice that we literally just take those corresponding terms and add those together. This table, it shows really good examples of that. Let's actually apply it. So they want us to add these two matrices. It reiterates that it has to be the same size. These both have an order of 2 by 2, 2 rows by 2 columns. So I can go ahead and proceed. When I go to add, I'm going to take the top left element and I'm going to add those. So 2 plus 7. Got that from here. Moving over to the right, so first row, second column, I have -3 plus 4. And then if I move down to the bottom right, or bottom left, then I have 0 plus -3. Should have put brackets around that one. And then in the bottom right, I have 5 plus -2. Okay, but I'm going to simplify that. So 2 plus 7 would be 9. -3 plus 4 would be +1. 0 plus -3 would be -3. And then 5 plus -2 would be +3. So match those terms up, match each element up, and that's what we add. And this explains why we can't have matrices of different sizes, because then I would have had an extra row or an extra column with nothing to add it to. Oh, this one has answers on it. Okay, that's okay. We'll still talk about it. Same thing here. They want us to add it, but we're actually going to do it in our calculator here. So I'll walk you through the calculator part of it. Instead of going through and adding each and every one of the elements like we did in the previous slide, you can actually save each of the matrices into your calculator and then add the two matrices together. So let's go ahead and do that. So from your main menu screen, you'll go ahead and press 1 to go to Run Matrix. Okay, then we're going to actually go to where we enter the matrices. So press F3. You'll see the arrow with MAT for matrix. And then notice that they give you all of these different matrix options, right? So the very first one is set to 3 by 4. That is not what we need, right? We have 3 rows and 2 columns. So I'm just going to start entering in the number 3, and notice that it opens up the dimensions for me. So 3 execute by 2. Once I enter in the values of the dimensions, then it actually opens up the matrix for me to enter in the actual values. So I have -2, 6. I would be careful entering these. Many times I'll just fly through them because I'm like, yeah, I'm just entering numbers. And then something will come up incorrect, and it's because I accidentally put a negative instead of, or I didn't put my negative in. So after I enter it in, I just go ahead and check it. -2, 6, -2, 6, -4, -2. Okay. After you've entered it in, then you'll exit out and we'll go down to matrix B. Again, I'm just going to start entering in the dimensions. So I'm going to press 3. Notice that it opens up that window for me. Then I put 2 for the number of columns. Go ahead and execute that, and then it opens up the matrix. So now I'm entering in matrix B. 3, -7, -2, -4, -1, 1. I check it. Okay, looks good. Exit out. You're going to exit all the way out back to this main screen. And now I have matrix A and matrix B saved into the calculator. So now I can actually reference them. I'm going to go to Shift 2 so I can access this matrix right here. And then alpha A, so now I'm dealing with the red letters, plus, again, matrix, so Shift 2, alpha B. And voila, it punches out my matrix. So definitely a lot quicker than me saying, okay, -2 plus 3, 6 plus -7, -2. Oops, my calculator is a little bit out of range. Okay, there we go. So it actually gives it to me. Also, it makes it a lot easier when I now have to subtract. So instead of then going back and going element by element, doing the subtraction, I can just do matrix A minus matrix B. I could even go up to where I had it originally written, delete out the addition, put subtraction in there, and voila. Notice that it went ahead and subtracted. So -2 minus 3 would have given me -5. 6 minus 7, which would have been 6 plus 7, right? Would give me +13, and so on. So that's the more efficient route of doing that in our calculator. And let's try it again. Okay, so with multiplication, we can definitely use it as well. With scalar multiplication, you aren't having two matrices that you're multiplying by. Well, I say that, but it's that scalar number out front is as if the matrix order is a 1 by 1, right? And so that value out front will just be distributed to each and every one of the elements inside of whatever you're multiplying by. So see in this example, our scalar value is 4. And in the matrix, we have 2, 5, -3, and 0. And so this was distributed to every single term. And then we have our answer here. So we can also do that in a calculator. Okay, they have matrix A and matrix B here. So we're going to go back into our calculator and enter that in. I'm going to go back to the main menu. Oh, I didn't need to do that. I could have just cleared that out. Let me delete this old information out. Okay, so F3 to get to matrix. I still have a 3 by 2. So I just pressed execute because I didn't have to. Now, if I wanted to change the order of my matrix, so the dimensions of my matrix, then I would have started entering the values, right? But because it's still a 3 by 2, I just pressed execute and it took me straight to the matrix. So I have -2, 6. Oh, it's the same numbers. Yay. Okay, I'm just going to go ahead and confirm that it's the same numbers for matrix B. Press execute. 3, -7, -2, okay, good. So same numbers. I'm going to exit out. And they want -3 times matrix A, right? When we enter it into our calculator, notice that, so -3, I have to put matrix A because that is what the calculator will recognize my matrix as. So shift matrix alpha A. And voila. Notice that -3 was distributed to each of those elements in matrix A. And then for the second problem, this makes you really thankful that you're using the calculator. They want -4 matrix A plus 2 times matrix B. So instead of having to do all that math, all that distributing, and then the addition between the two, we just put -4 shift matrix alpha A. Oops, not X, alpha A, plus 2 shift matrix, so shift 2 to get matrix, alpha B. And voila, we get all that done super quick. So definitely knowing how to navigate that calculator. How do I get matrix? I do shift 2, and that gets me matrix, and then I do alpha to access whichever letters I saved it under. So recall that we said that when you add or subtract matrices, they have to have the same order. They have to have the same dimensions, right? Because we're going from element to element. We're doing the operation between element and element. So in this case, notice that this is a 3 by 2, 3 rows by 2 columns, and then a 2 by 2. So the operation is not defined, meaning that we can't do it. But notice that B and C both give the answer choices. The operation is not defined, right? And then the reasoning is different. So the reasoning that you will choose for adding and subtraction is the difference of two matrices of different orders is undefined. So the difference, because they're asking us to subtract, of the two matrices is undefined. If we were dealing with multiplication, which we'll see here in a second, you would say the number of columns in the first matrix is not the same as the number of rows in the second matrix. But when we're dealing with addition or subtraction, it would be that the difference or the sum of two matrices of different orders is undefined. So this one cannot even be done. And if you enter it into your calculator, it'll give you an error message because it can't be done. Okay, so same thing here, right? We know just to punch this into our calculator. So let's get this out the way. Let me clear all this out. So these matrices are different. Going back into my matrices, F3, I'm going to enter -1. Oops. Sorry, I'm actually changing the dimensions. So I don't want to change the dimensions. The dimensions are still 3 by 2, 3 rows by 2. And so I actually could have just pressed execute. I accidentally pressed the 1, so it started taking me into the dimensions of it. But now I'm into the matrix. So -1, -1, 6, 6, -2, and 3. Check it. Okay, looks good. So I'm going to exit back out, go to matrix B, and my dimensions are fine, so I could just press execute and then start entering the values in. -1, -9, 8, 0, 8, -7. Check the values. Okay, values look good, so I'm going to exit out. Also, if your last value is a 0, so you already had a 0 there before you start entering your values, just understand that you have to press execute before you exit out. I've ran into that where I'm like, why won't it let me exit? So exit out all the way to the beginning. They want us to solve for 2x plus a equals b. Notice up here we have 1/2 times matrix b times matrix a. So let's talk about how we get there before we enter that into our calculator. So if they want me to solve for 2x plus a equals b, and I'm given a and b, right? So I'm trying to isolate x. So how would I do that normally? I would start undoing anything on that side that's keeping x from being isolated. So now I have 2 times x equals b minus a. You can divide both sides by 2. That's maybe where your brain's going right now, and that's okay. You can divide both sides by 2, and you absolutely can enter that into your calculator. Remember, another way to almost like undo the multiplying by 2 is to multiply by the reciprocal, which would be 1/2. So that's where we get that from. So I have x equals 1/2 matrix B minus matrix A. So that's what we're entering into our calculator. Get my calculator out. Do 1/2 times shift 2 to get matrix alpha A. Oops. And be careful, out of habit, I try to enter alpha A first, or matrix A first, but notice that the equation is matrix B. So alpha B. And then minus shift 2 to get matrix again, alpha A. Okay? And we get 0, -4, 1, -3, 5, -5. So we got 0, -4, 1, -3, 5, -5. All right, let's check out this next one. Okay, the equation, let's just look at the equation first. B minus X equals 3A. We're solving for X, right? Matrix X, and we're given matrix B and matrix A. So I need to isolate X. I'm going to subtract B. Do that on the other side. I have negative X equals 3A minus B. I can multiply by -1. Do that on the other side. And I get X equals -3 times matrix A plus matrix B. Okay? All right, so let's go ahead and do this in our calculator. So let's go ahead and access the matrix. So F3. My dimensions are still 3 by 2. So I can just go ahead and press execute. If they were not, remember that I would start entering in whatever the dimensions were. Gotta move this down a little bit. Okay, we have -5, -2, 6, 6, -7, and +5. I check my values. Okay, they're looking good, so I exit out. I go down to matrix B, enter in the values there, -3, 0, 6, -1, 1, 0. Check my values. Okay, exit out. Now my calculator has them saved in, so I can go ahead and enter this in. So we have -3 times matrix A. So shift 2 to get matrix alpha A, and then plus matrix B. Whoops, not what I was trying to press. There we go. All right, we get 12, 6, -12, -19, 22, and -15. That was a negative.